never send you to that. I always sit over there, you always sit over there. Let's mix it up. No? All right. You know what? I'll just go back. I like helping. That's fine. Change is bad.
Okay.
Change is bad.
Dash out. This is the all, wasn't it?
Yeah. Cool. Everyone, read text with this font.
Yeah.
Cool. All right. So, everyone's ready. Looks like the
Is anybody there? Did you
Camera?
share your stuff?
oh.
I know
Routed.
Jordan was going to go on there.
Yeah, it's running, right?
Oh,
If it says record.
yeah.
But it
says
doesn't show,
record.
it doesn't show like a,
Okay.
it doesn't show a timer, it usually shows a timer.
Yeah, probably.
Yeah, and I'm gonna be so lost if you're not here doing this.
It's recording.
Is it good?
It's fine.
I guess it's good.
All right. Oops.
Nice. Quality software in 2016.
Oh yeah, LibreOffice Impress. Which is also why I'm switching back and forth between a terminal and not embedding code.
Exactly.
So over the summer I played a lot with Rust. I kind of started a little bit at the end of last semester, and it has some interesting differences between lots of more common languages that I'm going to talk about today. So first I'm going to talk about what Rust aims to be and kind of what its target audience is. And then I'm going to talk about a couple of just interesting features that I think that I really enjoy about Rust that aren't necessarily totally unique, but they set it apart from some of the languages that are more similar to it. And then I'm going to talk about the memory model, which is kind of the big thing that separates it from everything. And then I will talk about the like what I think of it overall. So Rust aims to be fast, safe, and lends up to concurrency. Its main competitors are supposed to be like C and C++. It's supposed to encroach on projects that use C and C++ mostly, which is difficult to do because a lot of it's difficult to focus on performance at the level of C and C++ and focus on safety at the same time. Yeah.
The mic isn't on.
Should I use the mic?
You should try to make it so that they can hear you.
Oh, the.
Yeah, on the Hangouts.
Okay.
Aaron just getting slack.
Is it on now?
Yeah.
My mic is muted actually.
Looks correct.
Okay.
Okay, you're good.
Okay, cool.
Sorry about that.
Yeah, thanks. Also, I would guess there's kind of a disparate knowledge of like memory stuff in C++. So I'm going to try to explain in addition to explaining the way Rust solves things, I'm going to try to explain what a data race is and stuff.
Sure.
So if I assume too much, if I assume people know random stuff, feel free to interrupt and I'll try to explain stuff more. So in general, the languages that try to target a lot of the same space as C and C++ in terms of speed, or rather the languages that try to improve on C and C++ by being safer, usually sacrifice quite a bit of speed because there's they essentially have to make up for it by doing lots of runtime checks, which is, of course, slower. And C just does some drastically insecure things like not zeroing out memory or not doing bounds checking or whatever that any secure language can't compete with. But Rust takes kind of a novel approach to checks on memory errors at compile time. Excuse me. So when Rust inevitably takes off, it should have quite a few good applications. Because it has a very efficient runtime, it should be very good for embedding in other languages, for app development or just low-level programming in general. So you should be able to write operating systems and touch drivers well with it. So for example, there's a project Firefox to write an operating system in Rust, and I'm going to talk more about that in a little bit. And then one of the big projects in Rust is Servo, which is Mozilla's attempt to like rewrite the browser from the ground up using Rust, which has been going on for a while. But so like it's actually yielded some. It's actually been fruitful. I think in the latest, or maybe the second latest release of Firefox, a little bit of Rust shipped in for the media parser, which makes sense because media parsing is something that you want to be fast, but also something that you would like be concerned about if it wasn't secure, because it's like, you know, it's the kind of content that users or malicious users could you know, manipulate to try to take advantage of something. But and then Broadly is a similar project. Broadly is, I believe, a Dropbox project for how they compress files. So it's used in the industry in Dropbox. So one example that I want to talk about, because I think it's just awesome, is how Rust handles enums, because it's very different from most of the languages that I'm accustomed to. So a Rust enum can look just like a C-style enum, where it just has like an option, like something, some value it can have. But it can also store an arbitrary amount of data. So like if I want a value to store an integer, I can have the int type wrap around an I32, or I can have a point that wraps around two I32s, or I can have a complex type that wraps around a named 64-bit float and two named 64-bit floats. And then I can use them with nice syntax, like pattern matching and stuff. That's all, like if it's relatively high-level stuff, but it all only has compile time costs, right? So it's like pretty to look at. It looks almost Python-esque, even though it's operating at the level of C or C++. And it's not, you're not paying any runtime costs for things like this. And one of the benefits from something like this. So Rust also uses enums for how it handles errors by making generic enums. Oops. So like you can have lots of functions, instead of throwing errors, return results. Where if they complete successfully, then they return of type OK, wrapping around the result, or they return type error wrapping around the like a string that has the error message or the type of error that it throws or whatever. So it doesn't have like throw catch. It just returns like more interesting types. And then it also has, so result is commonly used and it's part of the standard library. And it also has which is like in C++ or something like that, instead of returning, like if you were returning a pointer or something like that, you want to check to see if it's a valid pointer, so you check to see whether it's null. This is the more elegant way of doing that. Like instead of just conveying some information based on the value of the integer you're returning, you convey information based on the type. So if you return a none, then you can't do arithmetic with that. But you could do arithmetic with a null accidentally. So it should, that's another thing that you can catch at compile time that like C or C++ would. So this is an example that I ran into a couple days ago, just totally accidentally. When I should have been actually doing offsets. But so for people who aren't super familiar with C, there's a big error here that's kind of difficult to spot. So if anyone sees it, feel free to shout it out, but I don't expect you to. So some background, in C, calling fork splits the process into a parent and child, or forks a child off of the parent, and then they both execute everything below the fork. So child, in this case the variable child, is going to be the process So the parent is going to have the process ID of the child in this variable, and the child is going to have the value of 0. So, so then if child, so essentially if the value is non-zero, so if we're in the parent, then wait 5 seconds and kill the child. Or if we're in the child, then do nothing. So it should just be an example of forking in C. However, it's C, so it's really unsafe. If you read the man pages, fork, if it fails, returns a value -1, which you should ordinarily check for. And that can fail if, like, I don't know, you have permissions issue, or if you're like out of processes to allocate, or if your resources are all gone. But so there are lots of reasons you could have -1 in the child value, and lots of people don't check for it because there's no reason that it's very easy to forget to check for it. It's like a corner case that isn't very common, and the compiler doesn't tell you to check for it. However, then we try to kill given the child PID, and if you read the man page for kill, you will see that giving it the value -1 kills all processes. So this is a very easy way to screw up really badly. And the compiler doesn't warn you about it. And the reason is because C is trying to communicate lots of different things in only one variable. It's trying to communicate the success of the call, as well as the process ID of the child, given that it was successful. Whereas Rust, if you use something,
You would just use none to indicate the -1 in Rust, and then you would use the multiple options in the enumeration,
yeah,
and wrap the actual result in order to communicate what you want to communicate.
yeah, exactly. So fork returns a result, and then make sure that it's of type OK, and if it's not, then it panics. And then, so it calls match on this, and if it's of type parent, then it can extract the child value using pattern matching, and then do what it needs to do. And otherwise, if it's the child and there's no data, then it can just loop indefinitely. So the Rust version does the same thing, but without the potentially really bad oversight. No, talk about this. So one thing that differentiates Rust from